Hi everyone, my name is Animesh and in this video I am going to talk about support vector machines. Our modus operandi would be first understanding the concept behind support vector machine, then we will build and understand that how a support vector machine model is built in Python. So let's get started. The support vector machines are primarily used for classifications. Let me begin with a classification problem. So, in this picture, here I have two independent variables, that is x and y, and one dependent variable that could be either circle or a triangle as shown in this picture. This classification problem is a linearly separable problem. I have the group points which are circles and another group points which are the triangles. These two groups can be separated with the help of a straight line. Now, taking the same problem one step forward and imagine the group of points are clouds in the three-dimensional space. One group of circles, another triangles. Now, in this three-dimensional space, if a plane is brought which can cut or separate these two group of clouds or set of points, then that plane is known as the hyperplane. So, the support vector machines are basically the tools that allows you to find that best hyperplane which can separate these groups in a multi-dimensional space. Support vector machine is all about finding that best fit line or best fit hyperplane. Now, in this example, if we draw a line like this, which separate these two groups, but this line doesn't separate all the points. If we draw a line like this separates them all, but it is not the best fit line. If we draw a line like this separates them all and it is the best fit line. So here our objective is to find the best fit line or best hyperplane in a multi-dimensional space that separates the point in a test data. If we look at this picture, the two parallel lines on the extreme of our separating line are called margins. And so, how far do we need to move parallelly so that we just hit the circles on one side and triangles on the other side? These two lines or margins are equidistant from the best fit line. This is what support vector algorithm does. It keeps on iterating with the line that separates two groups and find the distance between the margins. The one that has the maximum distance is the best fit line. We can also say in three-dimensional or multi-dimensional space that if such a hyperplane exists, it is known as the maximum margin hyperplane, the hyperplane that we want to find out. And so with the help of this hyperplane we can classify our data points. So now let us do a hands-on project on support vector machine model building. So let us import necessary libraries like pandas as pd, numpy as np, matplotlib.pyplot as plt, and cbon as sb. So now we make our dataset on which we will run our machine learning model. So the dataset that we are going to build is distinguishing the family car with the sports car. The dataset contains the variables like engine power and brake horsepower, wheel diameter in centimeters, and the car category. That is, it is a family car or it is a sports car. Here in this dataset, our independent variables are the engine power and the wheel diameter, and our target variable is the car category. Now we convert our dataset into data frame using pandas library. Here we draw a scatter plot between the variables, and here you can easily see that there is a separation between the target variable, that is the family car, and the sports car. We now separate our target variable with all the independent variables. We now split our dataset into train and test dataset, and the test size that we are going to take is the 30%. We mentioned 0.30 for 30%. Similarly, if we want to keep the test size as 20%, then we mention over here 0.20. So now we are all set to go for building machine learning model. So we import the necessary libraries for support vector classifier, that is from sklearn.svm we import svc, and we also import accuracy score from sklearn metrics so that we can measure the performance of our model. So now we build our model. We assign model as SVC open close parenthesis, and then we fit the model with the X train and Y train. And after that, we are going to predict model dot predict with X train. Here we get the prediction with the training data set. Now we are going to measure the accuracy score of our trained model on the training data set. We are going to print the accuracy score for training data. And now, with the help of the model that we have built, we are going to predict the target variable with the test data. And let's see what the accuracy score we get on the test data. The accuracy that we are getting is 100% for the training data and 75% for the test data. Hope you guys have by now got an understanding of how a support vector machine learning model can be built using Python. So, all the best and thanks for watching. I'll see you in the next video.